Okay, today we're going to run experiment 8, determine molar volume of carbon dioxide. So we will assume carbon dioxide in ideal gas. So we will have ideal gas equation PV equal to nRT. And 1 mole of the ideal gas at the standard temperature and pressure, STP, standard temperature and pressure. That means 0 degrees Celsius and pressure is 1 atm. Volume is 22.4 liter. That means 1 more hydrogen gas at STP, volume 22.4 liter. If 1 more carbon dioxide at STP, volume also 22.4 liter. Even though mass of 1 mole hydrogen gas is 2 grams and carbon dioxide is 44 grams, but their volume are same at the STP. So if we measure the volume of known mass of an ideal gas under one set of conditions, like pressure, temperature, then we can calculate the volume of the same gas under another set of conditions, so another pressure and temperature. So it's because ideal gas equation tells for fixed amount of gas, so fixed amount of gas is more is fixed. So PV equal to nRT, then N equal to PV over RT. Right. Under pressure P1, temperature T1, and volume will be P1. Then under pressure P2, temperature T2, your volume will be T2. R gas constant, exactly same. So both are same. So this equation becomes P1 V1 over T1 equal to P2 V2 over T2. So if we run experiment, measure the volume at pressure P1, temperature T1, then we can calculate V2 at pressure P2 and temperature T2. So from here, V2 equal to P1 V1 divided by T1 times T2 divided by P2. So here, P1, T1. P1, T1. Today's pressure and temperature in lab. This will be a known value. And already listed in the data sheet. Just read the data sheet. And V1 is the volume we measured in lab of a volumetric actually as an early flask. So these volumes measured under P1 and T1. Now this volume comes from the volume of water in the same flask. So what is the procedure video on the blackboard to place on the same place under lab 8. And T2 are standard temperature and pressure. So standard pressure is 1 atm. Standard temperature is 0 degrees Celsius. Of course, in the calculation, we must convert 0 degrees Celsius into Kelvin. So any temperature in ideal gas equation must be in Kelvin. So T2 are standard temperature and pressure. So convert 0 degrees Celsius into 273.15 K. And volume V2 or the volume of carbon dioxide at standard temperature and pressure. So under this condition. So this V2 will be calculated. From this formula. After we calculate V2, we can convert it to molar volume because our target is molar volume of carbon dioxide. Molar volume means volume of 1 mole carbon dioxide. So molar volume equals to V2 divided by moles of carbon dioxide. Moles of carbon dioxide come from the mass divided by molar mass. Okay. And molar mass for carbon dioxide, we can calculate from the formula, right? Carbon dioxide, 1 carbon. Carbon is 12. 2 oxygen. Each oxygen 16. Then 44.01. Per mole, right? And the mass, you need to watch class video how to calculate M from the experiment determined mass of flask plus mass of cork plus air in the flask. And after carbon dioxide evaporate inside the gas, inside the flask, and air will be pushed out, so inside the flask. So initially, in early mirror flask, you have air, and this is the mass of flask plus mass of cork plus mass of air, right? This is the first time you measure the mass. Then after you put some carbon dioxide, solid carbon dioxide is solid, then evaporate becomes gas, then carbon dioxide is heavier than air, so we're push air out. So air organ. So inside the flask becomes carbon dioxide now. Now second time the mass is flask. Cork still there. And this time no air becomes carbon dioxide. So if this is M1 and this is M2 and M air come from volume of this flask multiplied by the density of the air. Volume flask is volume air times the density. Right? And the density of the air depends on pressure and temperature. It will be listed in the data sheet. And the volume we use water. After this carbon dioxide evaporate, we cook it and label this position. Then open cork and then fill in water to here. Then where water's volume equal to volume of the flask. Then from water of volume, you get a volume of flask. Then from volume flask times the density, you get air mass. Then from these two, so you find M2 minus M1 flask cancelled, cork cancelled. So M2 and minus M1 becomes M carbon dioxide minus M air, right? And M air is this. So you can calculate carbon dioxide mass is M2 minus M1 plus M air, so air mass. So this way you find mass of carbon dioxide. The mass of carbon dioxide divided by molar mass of carbon dioxide, you get moles. Then volume V2, you calculate from here, divided by moles, you get a molar volume of carbon dioxide. So again, this how to calculate the mass of carbon dioxide also have formula listed in the data sheet, in a separate sheet for calculation of lab 8. Anyway, similar as here I explained. So again, we have video shows experimental procedure. I placed at the same place of this lab. So watch that procedure video carefully. Then you need a complete lab report together with pre-lab and post-lab.